Hello. In this video, we are going to learn how we can do a roof plan and a section. If you like, you can have an A4 paper and do the exercise, this drawing exercise with me. While we are watching the video, you can pause it time to time to hand draft. So if you have a T-square and a Z-square and an A4 paper, you can prepare it right now. Fix your paper on the table and place your T-square and Z-square and all the other drawing equipments. And let's learn how we can express our structural decisions via this plan and section. And we need to examine how we can do the scaling and page design, page organization. Uh, in order to do all these drawing, we need to remember how we designed reinforced concrete building structure, and then we need to remember how we designed the timber roof structure. And once the drawing is completed, then we need to put the dimensions, show the levels, and write the products on this drawing. Let's start with roof plan and section. You remember this example, it's a very tiny building. Let's imagine that we have this building here, only one story ground floor. It has only one floor. And over that, we have this shed roof with a 45% slope. And this is what we see. It's surrounded with these parapet walls, and we have this uh, uh, cantilevered part here in this eave part, and that's the ridge. And this is the surface, the finished surface. There will be some roofing products. Uh, but first, we need to design the structure and indicate express the structural decision so that the builders and the engineers can do the roof structure first, and then they can uh, put on all the other products, all the other components over the structure. In order to, once we design the structure, we need to express our decisions by drawing, making that drawing. And in order to do that drawing, we just imagine that all the roofing products are being elevated and there's only roof structure left. I think you remember the rafters and the purlins and all the other pieces that we learned last week. And we just imagine ourselves that we are looking down. This is how we can describe the roof plan. We first imagine that all the roofing products are being elevated and there's only roof structure, and we are in mid-air, floating in mid-air, looking down, and we need to draw what we see. In normal conditions, when we say a plan, we are talking about a horizontal section. But as you can see here, we need to look down. So it's not a section, horizontal section. There will be no cut surfaces, but there will be all seen surfaces. When we are at that level and looking down, we are just seeing all the upper surfaces, top views of all these pieces. And this is what we need to draw. There is one exception. If there is a chimney, in this example, there is no chimney, but let's imagine there is a chimney like that. Then we are cutting it horizontally, only the chimney. We are cutting it horizontally and we elevate all the roofing products and we look down and we need to draw what we see. So since we don't have a chimney, then there will be no cut surfaces, only seen surfaces. But that's the description. Okay, but first we need to construct the reinforced concrete components of the building, including that floor area. Here there is this reinforced concrete floor with the cantilevered part, and we can make sure that just like what we have learned last semester, there will be reinforced concrete beams supporting this floor, and these beams will be supported with the columns on four corners. And we need to construct all these parapet walls out of reinforced concrete. Otherwise, there is this risk of falling down if you use any other material, like bricks or AAC or some other material. Then they can fall down during an earthquake or a strong wind. Uh, so we need to do them out of reinforced concrete. But first, let's imagine that there is no structure, roof structure yet. And this is what we need to start drawing. Right now, just ignore these rafters. There are two rafters, just ignore them. Imagine that there is no rafters. Uh, this is what I am looking at. I'm seeing this surface here, and I'm seeing the top view of these parapet walls here, and you can see the dimensions. But first, let's do the drawing. These dimensions are for you to do the drawing. Draw this roof on your paper, so you don't need to draw the dimensions yet. And once we do the plan, we are going to cut it through. Right now, there is no roof structure, and there's only reinforced concrete floor surface and reinforced concrete parapet walls on three sides. When we do the section, we just imagine ourselves that we are cutting the building this time vertically in this position, and we are separating the building, and we are in between and looking towards this direction. These little arrows indicate the direction that we are looking at. And here, by transferring all the information from the plan, we can create the roof section. Right now, there is only reinforced concrete parapet wall, reinforced concrete beam, floor, beam, and this cantilevered part. And when I look towards this direction, I'm seeing the inner surface of this parapet wall here. That's how we can do the roof plan and section. But in order to make the drawing, we first need to scale it. And the scale will be 1/50. So let's remember how we can do the scaling. Here we see the dimensions in the real world. These are true sizes. And in order to make the drawing, we need to imagine ourselves that we are scaling them by 1/50. So that's how we can think that if a 50 centimeter length in real world will be represented by 1 centimeter on paper, that's how we can interpret it. A 50 centimeter in real world will be represented by 1 centimeter on paper. Then we have a 300 centimeter here. Then we can imagine or make the calculation for how much 300 centimeter in real world will be represented on paper. It's easy to do the math. We need to divide it by 50. Then we will get this length of the roof will be drawn as 6 centimeter on paper based on the scale. Here we see a 400 centimeter. It will be represented by 8 centimeter line on the paper. This line will be 8 centimeter. Here we have a 15 centimeter. Then it will be 3 millimeters this time. There will be a 3 millimeter line gap between these lines because we are looking at the top surface, top view of the parapet wall here. And once we do the section, we will be drawing the beams and the floor and the beam, the other beam, and the cantilevered part here. And this parapet wall, as you can see, it's just one single object made out of reinforced concrete. And we will be looking the inner surface of this wall here. We remember the scaling. Let's talk about page organization. If you have an A4 paper, then you can create a title block like this. You can write the name of the course and the university and everything. Here, you can write classwork 4 and that date, 6th of March, 2026. Your name and surname here and number here. The sizes are not very important. You can have just 5 millimeter from these sides and 20 millimeter from the left side to create the frame of the title block. And that can be these texts can be like 3 mm high, so you can arrange it accordingly. And we are going to use this part here. If we place our plan here, but it shouldn't get so close to the title block because there will be dimension lines once we finish the drawing. So you don't want to get too close to these sides. You can have a nice gap on 3 sides and a nice gap on the upper part of the plan because there will be a section. If you draw your plan here, you can use transferring lines in order to create the section. Okay, we remembered how we can do the page organization. Let's remember how we are doing or making decisions about the reinforced concrete structural system of the building. Here on the section, as you can see, we need to draw the beam, and we have this 50 centimeter as the beam height and 10 centimeter for the thickness of the floor. That thickness can be 50 centimeter. As you can see, it's on the plan here. But what about the thickness of the beam? You remember that a reinforced concrete floor slab can be minimum 10 centimeter and it shouldn't exceed 15 centimeter because it gets so heavy and it will become so expensive. Instead of thickening the slab, we can put girders, additional support beams, and change the floor system. But in this example, we are only drawing these 2 beams because we just imagine that floor here, this floor surface, 10 centimeter thick floor surface, is supported with these beams under its 4 sides. This is how we imagine it. And there's 1 beam here and a 4th beam on this part. And once we do the section here, I will be cutting that beam and I will be cutting this beam. And as you can see, the cantilevered part is 50 centimeters. The only thing that has been that we need to cover is this thickness of these beams. So let's remember the appropriate dimensions for a reinforced concrete beam. This is how a beam looks like, and there are steel reinforcement parts, but we don't draw them, but we know that they are there. The thickness of a reinforced concrete beam cannot be smaller than 25 centimeters, so that's what we are looking for. And the height of the reinforced concrete beam cannot be smaller than 30 centimeters, but it's the minimum level. We need to do this rule of thumb, the calculation. We need to divide this span by 10. When we say the span, I'm sure that you remember, it's the length of the beam, the gap between 2 columns. Okay, we are just imagining ourselves right now that we are looking down this reinforced concrete structure without any roofing products, roof structure yet. And we need to be careful about our drawing quality. When I say drawing quality, I mean the thickness of the lines. There are 3 different thicknesses that we can use. This one is very thick and black. That one has this middle thickness and it's black. And this is very thin. This needs to be thinner than that, and grayish color, not very black. These 3 main line weights, line thicknesses, will represent different things on our drawing. So we need to be careful about our drawing quality, line weights, and line types, so that the workers and the engineers, the people who are going to build this structure, can understand our decisions correctly. Since we are looking down and there is no cut surfaces here, only seen surfaces, the top views of all these sides, we need to use this middle thickness line and do the scaling. As you can see, we have 15 centimeter. In real world, we need to always communicate with real dimensions. But on paper, we need to do the scaling. and 300 centimeters. The total is 315 centimeters. Here we have 15, 15, and 400 centimeters. The total will be 430 centimeters. You do the scaling, you fix the paper now. If you like, you can pause the video and do this drawing. And once you finish drawing the plan, uh, you can proceed to section. But first, we need to draw the section line. As you can see here, this is a different line type. It's not a continuous line. We need to create a line and a gap, a dot and a gap, line, gap, dot, gap. It goes like this, and there are two little triangles with pointing this direction, and we can give a name for our section like A, B, B, or something. But this line needs to be thick. It needs to be thick because that's how we represent the cut surfaces. Since this is the section line, this is the cutting plane, and it's something like this. We are cutting the building vertically and looking towards this direction. That means we will be cutting this parapet wall. We will be cutting through the floor and the beams like that. And in order to express those cut surfaces now, we need to use thick lines again at the same thickness. On the drawing, there can be some mistakes. You just ignore them. I don't have the time to redo the drawing. Sorry about that. And here, as you can see, these are thick lines, but the scene surface here, the inner surface of this parapet wall needs to be expressed with thin lines because it's the scene surface. And in order to make this drawing, we need to remember how we did the slope. Slope is 45% in this example. And as you can see here, there is this height for 45 centimeters or above the 10 centimeter thick floor. And it starts at this point and it's inclined for 45%. How we do this? We first create a very thin line. We can use this thin line now because it's a guiding line, very thin, very gray. First, we create this horizontal line for 10 units. This can be like 10 centimeters. And once you find the second point, you need to go upwards perpendicularly for 4.5 units, this time 4.5 centimeters. And you find the third and last point. The only thing that is now you need to do is combine the first and the last points with, again, very thin lines, and that's the sloped surface of your parapet wall, the scene surface of the parapet wall. And again, just do the drawing without the dimension lines yet. Once we complete everything, we will do the dimensions together. So if you like, you can just pause the video right now and do this drawing and be careful about the drawing quality, line weights, and everything. And once you do everything, you need to do the hatch. As you can see here, it's one continuous line, one dashed line, one continuous line at a 45%, sorry, not percent, 45-degree angle, and you fill all this inner surface of the cut surface. That's how we do the hatch. We need to fill the cut surfaces only, not the scene surfaces, but the cut surfaces. We know that all these parapet walls, they are made out of reinforced concrete, but only we fill these cut surfaces with the hatch, not the scene surface. Again, here, this is a scene surface, that's a scene surface. And once you complete the drawing without the dimension lines, you can keep watching it. And now we need to remember how we did the timber roof structure. We are just imagining ourselves that this roof structure is a load transferring roof. The loads of the roof will be transferred directly to this reinforced concrete building structure, beams and the floor and the columns and everything. But first we need to remember how we did all these pieces out of timber. As you probably remember from last week's course, these are the rafters, mertek in Turkish, and we can create them out of by cutting a tree trunk like this in different size pieces. That's what we call a dimension lumber, kereste. Each one of these pieces are called a dimension lumber. But that's the important part here. We need to prefer a hard and strong wood, like elm tree or pine tree or fir tree, something like this, because these will be structural pieces. And rafters, we need to remember that this dimension of the of one of these rafters is 5 centimeters, and that's 10 centimeters, and the length can be maximum 3 meters. Only one piece if we are looking for a one piece. As you can see, it's appropriate. The inclined dimension can be a little bit longer than 3 meters. That's this dimension here. But that's okay. That's not a problem. We just imagine ourselves, we put one of the rafters here next to this wall, and we put another one here. You can see the tip of it. And we need to fill the in between with rafters. But how many of these rafters do we need? We just need to remember that there needs to be approximately 45 centimeter gap in between two rafters. This gap can be like 50 centimeter or 40 centimeter, 42 centimeter, 48 centimeter, something in between 40 and 50 centimeters. That's how we can calculate it. We have this total distance. It's approximately 391 centimeters. If we divide it by 45, the gap, we can find this number, but we cannot place 8.6 rafters. This number needs to be an integer. Integer means tam sayı. Küsurlu sayı değil, tam sayı olması gerekiyor. Bu kadar adet rafter koymak için tam bir sayıya ihtiyacımız var. 8.6 tane rafter buraya yerleştirmemiz mümkün değil. So we can do the opposite. If we divide this number by 8, we can have the distance, the gap between rafters. It's approximately 49 centimeters. That means that based on our calculations, there will be 8 gaps here, total 8 gaps, and 1, 2, 3, 4, 5, 6, 7, 8, 9 rafters in total. And we are just imagining ourselves that we are looking down. That means that we need to draw the top view of these rafters. As you can see, they start at the end of the cantilever floor, and they go upwards parallel to this parapet wall. That means that the inclination, the slope of these rafters is also 45%, just like the parapet wall here. And there is this distance like 10 centimeters in between the upper surface of the rafter and upper surface of the rafter and lower surface of the parapet wall here. And since we are looking down, this surface, that's what we are seeing. We need to indicate a 5 centimeter in real world, 1 millimeter rectangle here, 1 millimeter rectangle here, and divide it by 8. There will be 8 gaps for approximately 49 centimeters in real world. Since these are also the seam surfaces, not cut surfaces, we need to use this middle thickness line. And here we go. We can make the drawing, do the calculation, and complete all the rafters. And right now, we are imagining that we are cutting through here for the section. As you can see, no rafter is being cut. That means once we do the section, the vertical cutting surface, and separate the two pieces of the building and look towards this direction, we will be looking at the inner surface of this rafter. That's the closest one to us. So we can use very thin lines, very gray lines to transfer this information here. And this time, since we are looking at this inner surface, we will be seeing this 10 centimeter height of the rafter. That will be 2 millimeters in 1/50 scale, and we are going to use the scene surface middle thickness lines. So you can do the drawing like this. You can start from here, do a parallel line to this one, and then go for 10 centimeters upwards like this, and then complete the drawing like that. Okay, that's the scene surface of the rafter, but there's a problem right now. All these rafters, they are falling down. There's no support. We need to put a support, and that's the purlin. Uh, there can be one or two or more purlins if it's in the ridge level, or it can be at the eave level. If it's on the ridge level, that's what we call it's the ridge purlin. If it's on the eave level, then we can call it a wall purlin. And we need to remember that the purlins are slightly bigger than rafters because this purlin is is carrying all the loads of these rafters. So for a timber purlin, we can imagine ourselves that we created this minimum 10 centimeter, minimum 12 centimeter piece, but the length must be maximum 4 meters this time. And we can only have one piece of rafter. Like that, we just imagine that there's a rafter under these sorry, one piece of purlin, and there's a purlin under all these rafters. And since we are just seeing it, there is no cut surface. We need to do the middle thickness line. That's how we can draw our rafters like this. And as you can see, this time with the section line, the rafter is being cut. That means we can transfer this size of the rafter upwards for our section and use thick lines, black and thick lines, because it's the cut surface of the rafter, and create this 12 to 10 centimeter box. And let's check if we are okay with the length of the rafter, if we can do this out of only one single piece. As you can see, the total length of this rafter is approximately 4 meters. So that's okay. We don't need a second piece for this purlin. Sorry about that. I keep mixing the rafter and purlin. That's purlin, what we are talking about. But while we are drawing the section, we need to be careful about these proportions. Here, as you can see, we create some sort of groove. Kertik in Turkish, kertme, çentik diyebiliriz. This groove here, so that the rafter won't slip down, and we will have a surface. If you just turn the rafter upside down, that's what we will be seeing, these grooves, so that the rafter will be connected accurately to the purlin without no risk of falling down or slipping down. Also, if you like, you can use something like this here. There's this purlin, and we have the rafter like this. And here. Now, if you like, if you want a more secure connection, then we can use a tiny L-shaped steel sheet, and we can use screws in order to fix it on this side, from this side, and from this side also. That means that if we do that, we need to draw this like that. Okay. That's how we do the section of the purlin, and the proportion can be 1 third of the purlin. If we have a 10 centimeter purlin in real life, then this connection can be over approximately 3 centimeters. That will be one third of the purlin. Okay, but how we can support the purlin? It will fall down. That means that we need these studs. And we can have a 10 centimeter to 10 centimeter one piece timber stud under this end, and obviously there needs to be another one, but we cannot see it here because of the parapet wall. We are still imagining ourselves that we are looking down. How we can see the stud here? We won't be able to see the stud because it will be blocked with these by these rafters and purlin, that rafter and purlin. And there's another stud here, the same thing here. Since we are looking down and we cannot see the stud itself because it's been blocked, it's under the purlin and the rafter. We need to use a different expression technique. That's in normal conditions, this is what we need to do for the scene surfaces. However, we need to this time use very thick lines and do a dashed with these thick lines. We need to create a dashed plus sign here and here. And that thick dashed plus sign will represent the studs. And once the engineers and the workers look at our drawing, they will understand that there is something beneath this sign here. But what about the section? Once we do the section and look towards that direction, we will be looking at the inner surface of that stud. So you can do the transfer with thin lines and use middle thickness lines to draw the elevation, the side view of the stud. Beneath the stud, we need a bearing plate so that we can prevent the punching. Bearing plate works just like the footing of the foundation, and the thickness of a timber bearing plate can be up to 5 centimeters. That means that there is a bearing plate, a small bearing plate here under this corner, and once we look down, we can be able to see with these middle thickness lines the corner of it, because some portion will be blocked by this purlin, some portion will be blocked by this rafter here, so there will be only one corner drawn, and the section we can use the transfer thin lines to transfer and use this middle thickness lines to do the side elevation again. Here we will be looking at the surface. Okay, there are two more pieces that we need to remember. These are the bracings, göğüsleme in Turkish. It helps with the load transfer. All the loads of the rafters and roofing products and everything will be transferred to the purlins, and the purlin will transfer its loads to studs. But if we put these bracings, the transfer will be in a better way. And this is how it looks like if you are under the roof. That's a real life example from last week's course. But in this example, the stud is in the middle of the roof, and there is this purlin, a continuous purlin. So the bracings, they are symmetrical. But in this example, we have only one bracing because there is this parapet wall, and it will be enough. There will be bracings like this, and once we are looking down for the plan, we won't be able to see the bracing because it will be blocked by the purlin and the rafters. So we just skip the plan and go to the section. this time. Once we cut vertically and look towards this direction, we will be seeing this surface, lower surface of the bracing. Since it's a seam surface, we need to use middle thickness lines. And as you remember, the stud was 10 centimeters. The bracing can be 8 centimeters, so we can draw a little triangle like this here. And last pieces are these two thin timber pieces to lock the system against the lateral load. This is what we call double colors. As you can see, if you have a stud in the middle, and we can use two pieces of these timber pieces. It's a thin piece, only 4 millimeters to 12 millimeters, and they will be placed on either side of the stud, and they will be connecting the purlin, the stud, and this one of these rafters like that. If we want looking for a more secure connection, then we can have grooves like that and a hole, and do the same or similar thing for the stud so that we can screw it in a more secure way. But again, since we have a small, very small building, a small roof, we don't need double colors. Obviously, there will be only one color on this side. On the other side, there's no need to put a color because there's parapet wall and there's no space left. Here, since it's 4 centimeters, please do the math and draw the upper view, top view of the colors. One here, one here. And for the section, when we do the vertical section and look towards this direction, behind the bracing, but in front of this last rafter, we will be able to see this 12 centimeter high thickness of color with the middle thickness lines like this, but we need to, of course, cut that part like that. Otherwise, it's not good. We need to cut it like this and get rid of this part because, okay, sorry about that. Like this. It needs to be like that. Okay. The colors are placed, the top view, the elevation, and everything. But there is a mistake here. Again, please forgive me about the mistakes. It should be like that. Not thick lines with thick lines, but thin lines. This is what we see. There's a rafter here, that rafter here. It's blocking the color, that piece of the color, that part of the color. So that's the rafter that we are looking here. And since the color is at the back, like that, we need to make the drawing like this. If you want, you can create these dashed lines like that. Okay. Let's move on. We just forget the wall purlin. Under these ends of these rafters, there needs to be another purlin with the same dimensions. And since we are looking down, we will be seeing the top view of this purlin. But as you can see, it's not at this edge, on this edge. There's a gap in between this edge of the cantilevered surface and the this side of the purlin. What is the dimension? In order to draw the top view, the plan, first we need to do the section. Since we are doing the section, we are cutting that purlin vertically. That means that we need to use thick lines this time. And here, you can do it like this on the section first. And then once you create the section, you can go back to the plan. let's remember the proportion here, 1/3, 1/3 of the purlin. So you can use your set square and uh, do this drawing, find the spot. Uh, uh, you don't need to calculate that distance. You can just use your set square to find the spot here. Once you do the section, you can transfer it to the plan this time, like that, and do the top view with these thin lines. Okay, everything is being completed. The only thing that we need to check is, as you remember from our last week's course, the gap between two purlins needs to be maximum 3 meters because that's the maximum length of one of the rafters here. If you are looking for a one-piece rafter, of course, uh, that's the length of the rafter. Let's check. It's okay. It's 3 meters, so we are safe. We did the timber roof structure, the top view, and the section. The drawing is being completed. Now we need to do the dimensions. And first we need to remember how we can create the dimension lines. If there is a piece, a component, an object, this can be the top view, or this can be the elevation or the cut surface for the plan or section. It doesn't matter. And if you want to indicate this size of the object, first we need to create a line. It needs to be slightly larger than this size. And we need to create these two more lines. As you can see, the size of this part needs to be equal to this size of this part, and they need to be all equal. But this is longer, like that. You can imagine it like a little arrow indicating this direction towards that direction. And you need to put these 45-degree little lines here. And you need to write the number of the real size, not the scale size, but the real size. And it needs to be in centimeters. But you don't put C and M letters here. Just you need to write the number above the line. And the minimum height for a visible text can be 2 millimeters. It shouldn't be smaller than 2 millimeters. If you want to give the real size of this side, you need to do the same. And it's better for you to leave approximately similar gaps. And you need to do the length equal here, and these lengths, they need to be equal as well. And these 45-degree little lines, they need to be equal as well. And you write the number like that on the left side of the line this time. This is the dimension line, and these are the extensions. And this time, we need to find a thickness, a lineway that is in between this seam surface lines and cut surface lines. It needs to be a little bit thicker than the seam surfaces so people can uh, understand that it's a different type of line. Here, uh, there's a reason why we do the texts like this. This one is like that, and this one is on the left side, and it's been written on this direction. There is a reason for that. This is how we are looking to a page like this. That's the correct position. But if you need to rotate it, and you do the rotation like this time you will be able to read the text, still read the text. If you use a different direction for the text, then it will be upside down once you rotate the paper. That's why we need to be careful about these directions. And there's a reason for why we are extending this line towards the object like this because the same here. On your drawing, there will be lots of different lines here on this side of the object. If you just leave it like this, if you have equal lines, then people won't be able to understand if you are referring for this object or this object. There will be a confusion, and that object can be slightly different. So you need to do it properly. It's the same for this direction as well. It needs to be longer if it's the size of this object towards this side, and if we are creating a dimension like line for this object, then we need to have the longer side towards the object like this. But again, we need to write the numbers on the correct direction. These are like little arrows indicating the side or the direction of the object. Okay, this is a general rule for dimensional lines. Let's put them together here. If you are doing the dimensional lines on a section, the lines needs to be only vertical. We put the dimensions of all the heights of these objects. But for the plan, we can use both X and Y directions like this. Just ignore this one. Okay, again, there is the images has been mixed. The order of the images has been mixed. Let's start putting the dimension of the reinforced concrete component first. Here, we need to give the dimension of the parapet wall and the thickness of the parapet wall, so the workers can do all the parapet wall, this side and this side of the parapet wall out of reinforced concrete. And for the section, we need to put the dimension of the height of the beam, height of the thickness of the floor slab, and obviously the height of this parapet wall here, and we need the total dimension. We need to create a second dimension line and give the total size here. And we need to do the same for this the direction on the plan. 15, the thickness, the 400 meters, this gap in between two parapet walls, and 15 again thickness. And here we need to do the total height of the beam, including the floor thickness. And again, we need to do this total distance, the size of the parapet wall. With all these dimensions, they will be able to do the reinforced concrete components, the parapet walls on three sides, reinforced concrete floor slab, reinforced concrete beams. And now we can move on to the timber pieces, the dimensions for the timber pieces. We need to give all these sizes so that they are going to replace the timber pieces in their right position. Let's start with the studs, because once they create the timber reinforced concrete structure and once it's completed, they will move on to the studs. First, they are going to place these studs and bearing plates under the studs. And if we give a dimension like this, it starts at this plus sign, the middle part of the plus sign, and goes up to the other plus sign. Then they will be able to place these two studs with a gap in between for 386 centimeters. And we need to give the thickness of the bearing plate. Here in this example, it can be 3 centimeters or 5 centimeters, like that. And the total height of the stud will be 116 centimeters. But if you use 5 centimeters, then you need to change the number to 114 centimeters. And we can give the total dimension of the purlin here, and we need to indicate the position of two purlins starting from this side of the cantilevered floor. We need to go left side for 28 centimeters in order to place this wall purlin here, and there needs to be 265 centimeters between this purlin and that stud or purlin horizontally. And please forgive me about the mix again here. It needs to have all these things. As you can see, the purlin is vanishing, but just ignore it. It doesn't matter. And we need to give the total size of the rafter. As you can see, it's slightly more than 3 meters, but it's okay. It's very, very few, not that much. It's okay. Okay, and the last of the dimensions can be the middle axis, the gaps between the middle axis of these rafters. And these were 49 centimeters. We don't need to give all of them. We can just have one or two of them, starting from this end and go downwards. And we did the studs, we did the purlins, we did the rafters. The workers will be able to cut these pieces in these dimensions and place them on their correct position over the reinforced concrete roofs, reinforced concrete building structure. Here we need to indicate the total length of this color, as you can see, but we won't be able to give the sizes of the bracing. In order to do that, we need to have another section like this and look towards this direction so that we will be drawing the front view, let's say, of the roof, but we don't need to do that for this exercise. Dimensions are completed. Let's do the levels now. This is a level sign that we use for a plan. And here we need to have these lines and the circle, and we need to write the number in meters this time, not in centimeters, but in meters this time. And we need to place a minus sign or a plus sign based on the ground floor. As you remember, first we need to do once we do the foundation, that's how the building looks like. That's the grade level, subasman düzeyi. And that's our 0, 0 level. And there is plus and minus on the left side of the 0.00. That's what we have. This level, the upper surface of the grade beams and grade level is our 0, 0 level. And once we do that, we do this reinforced concrete building structure like this. You remember that. And this upper surface of the floor, that floor, will be higher than 0, 0. That means that if we are placing a level sign over this surface like this, it needs to start with plus because it's above 0, 0. If you are referring to something that is lower than the grade level, then it will start with minus 0.45. And as you can see, it's in meters. That means that if I place this level sign and write minus 0.45 here, it means that this grade level is 45 centimeters. The upper surface of the ground is 45 centimeters lower than 0, 0 level. Okay, that's the sign that we use for plan. That means that if we place it here, we can place it here on a horizontal surface. It will be the upper surface of the floor. We don't place the level sign on a sloped surface because if you place it here, it will be a different level. If you place it here, it will be a different level. If you place it here, there's a different level. Don't use level sign or to over a sloped surface, only use it for the horizontal surfaces. If there is a horizontal surface, then you can use that level sign on your plan. And that's for the plan. You can imagine it, it's something like this. It's what we call a plumb bob, şakül in Turkish. And you just imagine that you are giving the level of this end tip here, and you are using a device like this. That's its top view. You are here again for the plan and looking down. This is what you see. You see a circle, that circle, and in the center of the circle, there is this plus sign. So the plus sign will create this center, this rope here, something like this, and you write the number above the line for the plan. And you can create the line, all these lines like this. For the horizontal line, you can use 11 millimeters on your paper. For the vertical one, you can use 4 millimeters. That means that these will be 2 millimeters, approximately 2 millimeters or something. The radius of this circle can be 1 millimeter. And for the text height, you can use 2 millimeters again. That's how you create the level sign for your plan. And for the section, you just imagine that this time you are here in front of the plumb bob and you are looking towards this direction. That's what you see. You see a triangle this time. Okay, I'm going to change the. You see a triangle this time. This is how you can imagine it. You can just transfer it like this and create a little triangle and do this horizontal line so that you can write the number here. This sign is for sections and elevations, and that sign is only for your plans. Here, you can write the number, same here. For the sections and elevations, if you are drawing an empty triangle without a solid black hatch, that means that you are indicating the level of a finished surface. When I say a finished surface, first we do the reinforced concrete floor, and over this reinforced concrete floor, it's an unfinished surface. We can place some finishing products like floor coverings or maybe insulation layers. And if this is the upper surface of the unfinished reinforced concrete floor, you can place a thickness for the insulation, another thickness for the finishing floor finishings, döşeme kaplaması. Then it will have a thickness like that. If it's an empty triangle without a solid black hatch, then it means that it's the covered surface, finished surface. In Turkish, this is what we call it, ince kot. That's the level sign, kot işareti for the plan and for the sectional elevation. If it's empty, then it's ince kot, covered surface, kaplanmış yüzey. But if it has a black solid hatch, here in this example, you see it red. That's to help you focus on this part of the image. But in fact, it's black. And then it's an unfinished surface. There is no covering, only reinforced concrete. Kaba kot, kaplanmamış kot. And that's for the section or elevation. We are giving the upper surface of this uncovered reinforced concrete floor slab. And in this example, it's plus 6.50. That means that if this is the 0 level, there's this grade level, the ground floor, upper surface of the ground floor, that's 0 plus minus 0 and this is minus 0.45, the upper surface of the ground here. And this upper surface of the reinforced concrete floor without any covering materials will be plus 6.50. That means that there is this 6 meter, 50 centimeter height in between the ground floor and the upper surface of this floor. And as you can see, it has this black hatch. And once we do the floor, we can do the same sign, but this time this has black hatch and this is empty. And write the same number here on our plan. That's for the upper surface of the floor, and it's right on the floor. But if we are doing this sign on the side, here we can give the upper surface of the floor, the upper surface of the parapet wall, and this level here. Then we are looking for a line, an additional line, because there's already a line for the cut surface of the floor, but there's no line here. So it's something like you remember that when we are doing the dimensions, it needs to be longer, like pointing towards this side to indicate that there is this object here, something like this. The same thing. We are creating some sort of arrow without the arrow with this line so that we are indicating the level of this point here and that point here and this point here. Okay, we can have the upper level of the double color, one color there, and the upper level of the ridge, that ridge purlin. And if we are having the level sign on the side, then we need to use the symmetrical sign. This time we have this triangle, black triangle here, write the number there, and do the line towards the opposite side, because it needs to indicate this level here. Okay, levels are completed. Now, for the last thing that we need to do is to write the information of the materials and the product. Let's do it together. Let's start with this bearing plate. First, I give the dimensions. It's 20 to 20, and the material, elm tree, elm bearing plate. And please write 5 here, because that's the thickness that we draw. And you need to do the dimension for 5 centimeters. Let's write this piece here and that piece for the section. Now we can write the studs. This time we are using a 10 centimeter to 10 centimeter. Again, stud made out of elm tree. And you can write it on the plan as well. You can write the color here. You can use a line to indicate the position of the color, and use the same sort of expression for your section as well. There's this purlin, and there's the bracing. Again, sorry about that, but I forgot the wall purlin. So you can write the 10 to 12 elm wall purlin, 10 to 12 elm ridge purlin here and here. And on the plan, again, write the wall purlin as well. We are writing all these pieces for the plan and for the section. Rafters, we can give the name for the only 3 of them. It will be enough. And here you can use a sign for the section. Reinforced concrete parapet wall. Let's write parapet wall, not gable wall, but parapet wall here. And you can write reinforced concrete beam, reinforced concrete floor, reinforced concrete beam, and that's it. The whole drawing will be completed, and that's it. Okay, we learned how we can express our structural decisions by making a drawing like this. Hopefully next week we can work on what if we don't have a floor to transfer the loads? What if there's no floor? It's just an empty gap. We are going to learn how we can design a roof like that. Okay, thanks for listening. See you